My dear student, in this video, I am going to introduce the integration by the method of partial fractions type 2. First type, we are using the linear factors px plus q by x minus a into x minus b, and px plus q by x minus a into x minus b into x minus c. Like that, we have seen in our previous video, the denominator term is linear factors. Here it's a squared factor, multiple factor. Second type, denominator term is a multiple factor. Px plus q by x minus a whole square. The factors of x minus a whole square are x minus a and x minus a whole square. These are the two factors of x minus a whole square. So this type is a denominator term consisting of a multiple factor. If it is so, we can solve one problem. Evaluate integral 3x minus 1 by x plus 2 the whole square. Here, the denominator term is a multiple factor x plus 2 the whole square. Therefore, it can be x plus 3x minus 1 by x plus 2 the whole square can be x plus dash a by x plus 2 plus b by x plus 2 the whole square. Like that, you have to split into partial fractions. The term integrand is split into two integrals of the form a by x plus 2 plus b by x plus 2 the whole square. Now, by the principle of LCM, you take this denominator term to the right hand side, it becomes, by as usual method, 3x minus 1 into equal to a into, if you bring it to multiply on the right hand side, it becomes a into x plus 2 whole square by x plus 2 becomes a into x plus 2. One term is cancelled. Similarly, plus b into x plus 2 whole square by x plus 2 whole square, cancelling both sides. Numerator and denominator, you will get just b only. So, to find out the value of b, we have to substitute x equal to minus 2. By giving x equal to minus 2, we can find b, that is 3 into minus 2 minus 1. 3 into minus 2 minus 1 equal to a into 0, minus 2 plus 2 is 0, plus b. So, minus 6 minus 1 minus 7. 6 minus 1 is minus 7 equal to b. Like that, we can determine the value of b. Similarly, by giving x equal to 0, we can find a. By giving the value of x equal to 0, you will get 3 into 0 is 0 minus 1. If you put x equal to 0, 3 into 0, 0 minus 1 equal to a into 0 plus 2 is 2. Plus b minus 1 equal to 2a plus b is minus 7. If you bring this minus 7 to the left hand side, it becomes plus 7 minus 1 equal to 2a. So 2a equal to 6. From this, a equal to 3. 2a equal to 6. From this, you can find a equal to 3. So, by substituting value of a and b, this integral can be split into two integrals by the method of partial fractions. Okay. See, this is the left hand side is integral 3x minus 1 by x plus 2 whole square dx is equal to a. A is 3. 3 by x plus 2 dx minus b 7 by or plus minus 7 by x plus 2 whole square dx. You can split this into two integrals like this. Substituting the value of a is 3 by x plus 2 into dx plus b is minus 7 by x plus 2 whole square dx. So this is to know the integral of 1 by x plus 2 is, if you take 3 common, 1 by x plus 2 is log of x plus 2. And taking minus 7 outside, 1 by x plus 2 whole square is 1 by x plus whole square is minus 1 by x plus 1. X plus 1 whole square, x plus 1 minus 2. X plus 2 power minus 2 plus 1 by minus 2 plus 1 is minus 1 by x plus 2. Sorry. Okay? So, integral of 1 by, you know the formula for integral 1 by x square. What is integral 1 by x square? Minus 1 by x. Because x power minus 2 is minus 2 plus 1 by minus 2 plus 1. This is integral of minus 2 dx. By the formula we get integral minus 2 plus 1 by minus 2 plus 1. This is x power minus 1 by minus 1. That is minus 1 by x. So instead of x you have x plus 2 whole square. Instead of x you have x plus 2. Therefore you get minus 1 by x plus 2. By this principle we can integrate this. So this is 3 into log x plus 2 minus of minus plus 7 by x plus 2 plus one integrating constant c. That's all about the answer for this integration. That's all about the problem. By the principle of multiple factors with the denominator, this is the method of splitting it into partial fractions, and the problem is solved like this. Okay? Next, type 3. This method, you have a linear factor and a multiple factor in the denominator expression. In the denominator expression, you have one linear factor and one multiple factor. This is type 3 method. In this method, we have to split into a by x minus a. Again, this multiple factor can be split into two factors, b by x minus b plus c by x minus b the whole square. So, one linear and one quadratic factor can be split into a by x minus a plus b by x minus b into c by plus c by x minus b whole square. This can be again split as in the case of the type 2 problem. This can be split as in the case of type 2, b by x minus b plus c by x minus b whole square. Like that, we have to split this expression. For that, we can solve one problem, evaluate integral. Consider this problem, evaluate integral 1 by x minus 1 into x plus 2 the whole square dx. You consider this problem, integral evaluate 1 by x minus 1 x plus 2 whole square dx. It can be split using this idea of the type 3 problem. This is numerator is just a constant 1 by x minus 1 into x plus 2 whole square equal to, you can split by a by x minus 1 plus b by x plus 2 plus c by x plus 2 the whole square. Like that, you have to split into partial fractions. Again, the term is to be contained by multiplying into the right hand side. You bring it to the denominator. A into x minus 1 by x plus 2 whole square. 1 x minus 1 is cancelled and you will get only a into x plus 2 whole square plus b into, you can cancel one term in the x plus 2 term only. X plus 2 whole square and x plus 2 cancel. You will get x minus 1 into x plus 2. So in the second term b into x minus 1 into one term is only cancelled. You will get another x plus 2. Another term is x plus 2. These method of partial fractions you have studied already. You have studied already in algebra. In your algebra chapter, you can study the method of partial fractions you have studied already. On the area of that, I am splitting the fractions and plus c into x plus 2 whole square is cancelled on both sides. You will get just a c into x minus 1 only. So from this expression, we have to find out the unknowns a, b and c. Constants a, b and c. For that, you first substitute x equal to 1. If you put x equal to 1, c 0, x equal to 1, if you put b is also 0, you will get just a. If you put x equal to 1, 1 equal to, right hand side a constant only you have, therefore 1 equal to a into 1 plus 2 whole square. X equal to 1, if you substitute 1 plus 2 whole square plus, if you substitute x equal to 1, 1 minus 1 is 0, 0 into everything is 0, plus substitute x equal to 1 minus 1 is 0, c into 0 is 0. Therefore 3 square is 9, 1 plus 2, 3 square is 9a equal to 1, so a equal to 1 by 9. Like that you determine the value of E. Again, if you substitute x equal to minus 2, A, B and vanished C you will get the answer for C, value for C. If you substitute x equal to minus 2, if you put x equal to minus 2, 1 equal to A into 0, minus 2 plus 2 is 0. Again, x equal to minus 2 plus 2 0 into B is 0, plus C into, if you put x equal to minus 2 minus 1, x equal to minus 2 minus 1 whole square, sorry, minus 2 minus 1 only. Okay? So 1 equal to minus 3C. Minus 1, minus 2, minus 1 is minus 3 into C, minus 3C. So C equal to minus 1 by 3. So we determine the value of C also. Okay. Next, we can find out the value of unknown B only. A is 1 by 9, C is 1 minus 1 by 3. Now we have to find out B. For that, you have to equate the coefficients of x square on both sides. Equating the coefficients of x square to find the value of B, here equating the coefficients of x square on both sides. Equating the coefficients of x square on both sides. Left hand side there is no coefficient of x square in the expression. Therefore 0 equal to x square coefficient is A, because if you expand this x plus 2 whole square you get x square into A. So value of x square is A. C into x only, that was the here. The third term there is no coefficient of x square. But in the second term x into x is x square into B. So coefficient of x square is of B also. So we get A plus B only. Coefficient of x square is A and coefficient of x into x is x square is B, and there is no coefficient of x square in the third term. So A plus B equal to 0. From that you know A equal to 1 by 9. So 0 equal to 1 by 9 plus B. From this you get B equal to minus 1 by 9. B equal to minus 1 by 9. A is 1 by 9, B is minus 1 by 9, C is minus 1 by 3. Therefore, our problem becomes integral 1 by x minus A, x minus 1 x plus 1 square dx equal to this one, C is minus 1 by 3. This becomes integral. What is A? A is 1 by 9. 1 by 9 into x minus 1 plus B is minus 1 by 9 into x plus 2. X minus 1 plus B is x plus 2 plus C is minus 1 by 3 by x plus 2 whole square. So the problem, after finding the values A, B and C, it can be split into partial fractions like that. A by x minus 1 plus B by x plus 2 plus C by x plus 2 the whole square. Now we can integrate it term by term, we will get the answer. Okay? C. For that, listen, we can split this into 3 integrals now. Okay? The single integral given is now split into 3 integrals. This is equal to 1 by 9 into integral 1 by x minus 1 dx minus 1 by 9 into integral 1 by x plus 2 dx minus 1 by 3 into integral 1 by x plus 2 whole square dx. So this is 1 by 9 into integral 1 by x minus 1 is log x minus 1 minus 1 by 9 into integral 1 by x plus 2 is log of x plus 2, direct results. Similarly, minus 1 by 3 into just we have to integral 1 by x square is minus 1 by x. Therefore, minus 1 by 3 into integral 1 by x plus 2 whole square is minus 1 by x plus 2 plus c. So this is answer. You will get 1 by 9 log of x minus 1 minus 1 by 9 into log of x plus 2. That term becomes minus into minus plus 1 by 3 into x plus 2. 1 by 3 into x plus 2 plus c. So that's all about this problem. By the third type problem is evaluated by using the method of partial fractions like this. So after finding the unknowns a, b and c, we can integrate term by term. We will get the answer for this problem. That's all about the problem. And thereby type 3 is over, and I will stop my video here, and we will continue in the next video, and we will see the next type in our next video. Thank you.